Hi everyone, this is continuation of our lab 7. We need to create this drawing, which is the power supply drawing. This PLC input ladder logic and wiring details. This is the PLC output wiring details, and finally the bill of materials. As usual, we will start with the easiest ones first, and we'll delay this first one because of the custom components that we need to create. So let's do the PLC inputs and outputs, and this is something for you to pay attention to, because you will see this wiring details in your PLC courses, as well as those of you who are going to have capstone projects using PLCs. So I've started my AutoCAD. Go to PLC inputs and notice how many rungs we need for this diagram. So we've got 2, 4, 6, 8, 10 rungs. So I'm going to go to my drawing and then go insert ladder, 10, tab key to see the update, and then we'll say OK, and then click to create, and notice these correspond to what is required here, which is actually starting at 6. The reason for that is because if you are to create this drawing first, the rungs would have started from 1 to 5, and the next drawing is continuing to 6. But since we started with the PLC input ladder, it is starting with 1. Of course, we can override that. We can right click, go edit component, and then here we tell it to start from number 6. And there we go. Now we're starting from 6, going all the way until 15, same as you see here. Of course, the top number refers to the sheet number, which you should have entered in your drawing properties in this space. Okay, let's do the PLC module, and these are realistic components. These are in fact components that we have in the PLC's lab. So this is an input module made by Allen Bradley, module number 1746 IB8. So we're going to go, and of course notice the wire details. We can leave these for later, or we can do them now. So I'm just going to leave them for now. We'll go to icon menu, and then we'll go to PLC IOs, PLC modules. Be patient until you get the dialog box, and then you want to expand Allen Bradley. You want to go to 1746, and that's what we have here. There are a number of modules. You want to say discrete inputs. You click on it, and then you click the plus sign, and you need to look for IB8. So we're going to look for IB8, and there it is. And that is the module that we need to insert in our drawing. So we'll just say OK. Now it gave me an outline. Notice the X. We will align the X with the first rung so that it will automatically complete the wiring for us. It says okay, spacing, yeah, we don't want to change that. That was inherited from the drawing properties. We'll say okay, rack number 1, slot number 2. We'll say okay. A starting address, we can see starting address is 0, so we'll just say 0, and then okay, and it performs the rest. Notice that we don't have a line here at rung number 15, so we're going to use trim command and trim this one. Okay, notice that this information is exactly the same as you see in here. It's PLC1, its module number is correct, rack and slot and so forth. And now we're ready to start placing these components. These are basically the same as you have done before. You need a temporary contact push button, so we're gonna go here. We're going to say push buttons, and there's the PB. Be careful with the snaps. Notice that as I try to place the component, that snap point appears, and if I click now, the part or the component is going to jump to the left. So I'm going to turn off object snap temporarily. Notice also the component is jumping, and that's because grid snapping is on, which is fine for electrical drawings because it will snap correctly to the wire. Notice that the functionality is in AutoCAD electrical is smart enough to break wires and rejoin wires if done correctly. So if I click here, notice that it has broken the line. If you delete it properly, meaning you don't use the delete key but you right click and delete, you will see that the wire joins. So I'm just going to say OK temporarily here, right click and delete component. You can see that it rejoins the wire. So we will do it one more time. And by the way, notice also on the right side there's this column that keeps the recently used components. You don't have to go again to this to search for a component if you have already used it and want to use it again. So I'm just going to place it, and the label is machine start. Okay, and part numbers we can do later on. That's good enough. Catalog lookups, we can do them together. Okay, the next one is mushroom head normally closed push button. So push buttons, mushroom head normally closed. We'll go here. Notice that it's not snapping correctly to the wire. So if you click now, it will not break the wire correctly. So sometimes you have to stop the snap, turn it off, and line it, and you're good to go. Emergency stop. Okay, this is good. Notice also the tags or the tag names. Some of you had problems in Lab 6. These tag names can be changed if necessary. You can go here and change it to whatever you want. Okay, the next one is a proximity switch, X positive axis or positive direction. So again, we go here and we look for these normally closed proximity switch. Look at miscellaneous, not there. And miscellaneous switches right here. There it is, normally closed proximity switch. Place it. PRS, it should be PRS1. Notice here it says second. So this acts like a child. It's not a parent component. So we don't want to use this one. We want to use this. So we're going to go here. This is PRS1, and we're going to call it proximity switch X plus axis. Okay, we'll copy this because it repeats. Also, it's useful to notice that we've got 4 of these. The only difference is that we've got different labels here. So instead of going to the components menu every time, we can say OK repeat. And here's the second one. And this one is supposed to be X minus direction, and then OK repeat one more time, and this is supposed to be Y positive direction, and then again one last time, OK repeat, and this is Y negative direction. And we'll just OK. Right, so notice also the tag numbers are correct. Now we need to look at these sensors. Again, we're going to go to the icon menu, miscellaneous switches, and there they are. One normally open photo sensor. So we'll place it there, and we'll call this part in position sensor. And we have another one, part correct sensor. So we're going to say OK, repeat. And it's going to say part correct sensor. And notice the tag numbers are correct. Okay, I think that is pretty much what we need to do in this drawing. Of course, notice the arrow pointing in from here and there, and these are called destinations. And if you go back to the power supply drawings, you can see arrows pointing outwards, and these are referred to as sources. So we'll do these later on. For now, we can define, when we do the sources and destinations, the wire types will follow what we have defined previously. So you can go to the change and convert wire types and pick the wire types that you want, or you can leave them until we do the sources and destinations. Some details are required still. I will leave them for now in the interest of time, but we'll do them later on. Again, something you can do is to align all the components together. So you pick one and then align all the other ones to it. Just choose all of them and then enter, and they align correctly. Always remember to save your work. When we're done, we're going to resize or rescale this. Don't do this rescaling until you're done with the other drawings. So now let's go and do the output ladder. And the output ladder, let's see how many rungs we need. Okay, we've got 2, 4, 6, 8, 10, 12. So we need 12 rungs. Okay, again, ladder. We need 12 rungs. Tab. Okay, pick a point. And feel free, if this overrides your borders, you can move it using the move command. Notice now it started correctly at 16 because it's picking up from where it left off. Okay, and ends up at 27. Again, sheet number 3, so everything is correct. We can pick up this module. Again, it's Allen Bradley output module, model number 1746-OBP8. So let's go to the icon menu and go to PLCs, PLC input output modules. Collapse this, discrete outputs. We're going to look for OBP8. Oh, be careful, there is OB8. That's not the correct module. It's OBP8. So let's just say OK. There's the module. This time we want to align to the left because this is an output module. And align the X with the wire and then click OK. Same as we did before. This is now still rack 1, but slot number 3. And the output addresses start with 0. Say OK, and notice that everything is done automatically. All the wiring is done correctly, and it's done. Okay, now we need a control relay or coil. Go to icon menu and relays and contacts. relay coil. Again, be careful with the grid snap, so you might want to turn it off, and then place the component and make sure the wire breaks correctly. It's called CR1. There is no description, so we'll just say OK. Next we've got green light and red light, LT2 and LT3. So icon menu, pilot lights, green, there it is. And this says LT1, so we'll change it to LT2 to conform to what is required. This is machine on. I will say OK. We can't say OK repeat because this is different light. So just say OK, and then we'll go icon menu again, pilot lights, red, and this one is emergency stop pressed. Second line is machine stopped. Emergency stop machine stopped. And this is supposed to be LT3, so we'll change this to 3. Okay, and then we have an alarm, so we'll go to icon menu and look at miscellaneous, and there's the buzzer, which is an alarm symbol. Place it there. Machine alarm. ABU1 is good. That's your tag number. We'll just say OK. And this is a ground connection or 0-volt connection to the module, so we'd leave that alone. Just that there. Next, we have a motor coil, M1, we have M2. So we go to icon menu, motor control, and we're looking for a motor starter coil. And this is called M1. We're going to call it X-axis motor coil. X-axis motor coil. Notice this is identical. We're going to call it Y-axis, so we're going to say OK, repeat. Just change this to Y. And then we have two white lights, LT4 and LT5. Pilot lights, standard white. And this is X-axis motion. X-axis motion, and we want this to be LT4. Okay, and then we'll go say OK, repeat, because it's the same light. And this one is Y-axis motion, and this is LT5. And we'll say OK. Okay, again, the last one is a electrical connection to the output module. And that is pretty much for the output module. So everything is okay, except of course the wire types and the source and destinations. We can do this also partially because there are some components that we have not yet defined in the first drawing. So again, we go reports, bill of materials, okay, do all, okay, put on drawing, okay, and it's showing me only PLC1 and PLC2 because that's all I have defined as far as catalog information is concerned. We'll just say close. Don't worry that it's not complete, because the next time you run the report, you can say update the existing drawing. So we can go to PLC input modules and now start placing the catalog information for these parts. So let's look at this. Of course, you may want to print this last sheet so that you don't have to look at it sideways, and that's what I have done. And the first one on the list is ABU. This looks like the we don't have to go by the in order in that list. We can go look for PB1. Where is PB1? It's right here, and it's made by Allen Bradley, model 800H BR6A. So we can go right click, edit component, lookup, be patient with the catalog, and again always remember to save. So there's BR6A 800H, and we'll say OK, and there it is, OK, and save. And you continue to do the same for the other components. So BP2, edit component. BP2 is also Allen Bradley. So lookup, and there it is, DR6A. Say OK and OK. Okay, you know how to do the rest. This is all catalog information. So I'm going to complete everything and come back with BOM. Okay, now that we've entered the catalog information, let's also do a quick alignment of the components. This looks okay. This one. Notice the line does not go all the way down, so we have to do those separately. Okay, so again, align. And you could have done them straight just to see. I think that AutoCAD recognizes all of them even though the line doesn't go down. Again, always save. Let's go back to BOM and go to reports. I didn't save previously and it did crash during the catalog lookup, so again, be patient, and as I said before, save every now and then. So that small schedule disappeared. We'll try again. Now it will have more of the required information. Do all. Okay. Again, waiting for it to come back. Okay, here we go. Put on drawing. And it's not behaving well. Hope it comes back. Okay, I can see here it says exception occurred, access violation. So, okay, let's try again. Okay, let's try again, put on drawing, and this is what I need to see. And as you can see now, the list is more complete. And notice also that we're just encroaching on close. We're encroaching on the limits of the title block. This is still okay, but when we add some more components, we will probably have to rotate the bill of materials. What am I missing now? I've got ABU1, CR1, LT3. I'm missing DS1, of course, and DS2, which are in the power supply. LT3, LT4, and 5 are also missing. Let me just save first. And let's see, LT4 and 5. Here we go. LT4, edit component, and it's obviously not there. Go lookup and drop down. We need to look at Fuji. Okay, and the part number is AH16, AH165-2ZWE3, which is this one. The other LT5 is the same, so I can copy. Okay, save, and then the next one, edit component, lookup, and uncheck, check Fuji. Okay, paste, there it is. Okay, save. So now let's see how to update this. We'll go reports, same as before. Reports, okay. Do all, okay. Waiting for it to come back. Notice here it says database query 2 of 5 is still processing. Hopefully you don't see access violation again. There it is. Say put on drawing, same as before. And there is the access violation again. It happens every now and then, so we have to deal with it. Okay, this is what I'd like to see. Notice that when I said put on drawing, this time it says update existing. It already recognizes that there is already a table, and that we can choose either to insert a new one or update the existing. So in this case, we'll just continue with update existing, and we'll close, and you can see that now we have LT4 and LT5. There's LT2, M1, M2, PB1, PB2. We've got PE1, PE2, PLC1, PLC2, and PRS1 to 4. So the only item that I'm missing are 2 DS or disconnect switches, 1 and 2. So we'll save this. We can go back to the digital inputs. And we can, this of course is the 24 volts positive, and this is 24 volts 0. So I can go schematic, and then like I said, you can do these as part of the source and destination, or you can do them directly. So let's say 24 volts DC. Okay, we'll choose this, anyone. Notice that all the shorted wires, all the interconnected wires will assume the same wire type. And let's go back again here to the input modules. Notice that these two are also the same, but these are different. This is the control wire. These are 3-wire control components. So let's go back again here and go change wires, wire types, 24 volts DC for the top 2. Then go back again and then output control. Okay, and we will choose 1, 2, 3, 4, 5, and 6. Enter. And then one more time for 0 volts DC. Okay. Enter. Then don't forget to save. Go to the output module. And if we look at the lab instructions, we find that this is, again, on the left side is 24 volts DC, on the right is 0 volts DC. So change 24 volts DC, OK. Enter 0 volts DC, OK on this side, enter. And these are 24 volts DC as well. This is a design choice. On this side, these are outputs. Notice this device, essentially what we're saying is that it receives positive on the one terminal and 0 volts on the other terminal. Okay, so 24 volts DC, okay. 1, 2, 3, 4. And same thing with the other components. 1, 2, 3, 4, enter. And that basically finishes the last 3 drawings. We're only left with the power supply, which will be the subject of the last part of this tutorial.